One method for solving a system of linear equations is known as the substitution method. It uses algebra instead of graphing and is thus considered an algebraic method. Sometimes, though, neither equation has a variable alone on one side. In that case, we solve one equation for one of the variables and then proceed using the algebraic method. We can solve either equation for either variable. Since the coefficient of x is 1 in the first equation, it's easier to solve that equation for x. To do that, we will add 2y to both sides, and now we have an equivalent equation to the original, but it's solved for one variable and set up for us to follow then the substitution principle. We will replace the x value in the second equation with what x is listed as equal to from the first equation that we've just altered. So to continue with our substitution, 3 times x is no longer 3 times x. We have replaced x with the equivalent given in the first equation, which results in the second equation all in one variable, which we'll go ahead and simplify then. First, distributive property to eliminate the parentheses results in 3 times 2y or 6y and 3 times 6 for 18. Combining like terms, 6 and 2y combine for 8y. Next, we want to get the variable by itself, so subtract 18 from each side, and last, divide both sides by 8, giving us a y coordinate that is common to both of these two equations. This tells us that these two equations, when graphed, intersect. We're not done though. A solution of a system of equations in two variables is an ordered pair of numbers. Once we've solved for one variable, which we have here, we need to find the corresponding value. We can replace y in either one of the two equations. The first equation is probably easiest since x is by itself. All we'll need to do is multiply our y value by 2 and then add 6 to that, which results in a corresponding x value of 5/2 and giving us the following solution to this system of linear equations.